Okay, on to respiratory challenge number 2. So again, I just kept this even though we're not identifying any new challenges, but we're talking about challenge number 2, which is high cardiac output leads to high pulmonary blood flow, which leads to high pressure. We have to minimize that pulmonary pressure. Okay, so like I just said, cardiac output increases during exercise. This increased flow causes pressure to increase, right? Remember the equation, pressure equals flow times resistance. Well, if we increase flow, we're going to increase pressure. And if we have high pressure, that's going to force fluid out of the capillaries and into the interstitial space. This could ultimately cause there to be fluid buildup in your alveoli, which is less than ideal. And to prevent that, we need to reduce pressure. And one of the things that also helps is the lymphatic system helps to drain and move away some of that excess fluid that might leave. The easiest way or the best way or kind of the adaptation that your lungs have is they do two things to reduce pressure. The first one is recruitment. And so we're showing that over here on the right side. Okay, so notice that at rest, we might not be recruiting all of our capillaries. We've got these capillaries kind of in the bottom right that aren't being used. Well, during exercise, we've got increased pressure, and that basically opens up these other vessels so we get more blood in there. And so if I have more places for the blood to go, I'm going to reduce the resistance. Okay, so there's going to be less pressure. And then I can also distend capillaries. And so we take the ones that are already open and we actually increase the space that's in those capillaries, increase the radius a little bit. And if we increase the radius, we decrease the resistance, we decrease pressure. Okay, and we can see that with this figure here. So on the x-axis, we've got cardiac output. On the y-axis, on top, we've got resistance. And notice the resistance is relatively high at rest, but when we start to exercise, resistance actually decreases fairly substantially. Okay, and part of the reason is that we minimize pressure. Now, the pressure, when we go back to that equation, flow equals pressure over resistance, you have to remember that pressure is a gradient. Okay, and so that's the difference between pulmonary artery pressure and pulmonary wedge pressure. And pulmonary wedge pressure is essentially the pressure in the capillaries. Okay, the reason they call it wedge pressure is they take a catheter and they push it up through your arteries, your pulmonary artery, and they push it until it's wedged, literally wedged in your capillaries and can't go any further. Okay, and so notice that even though this pressure is going up, the gradient or the difference between the two staying the same. Okay, and so the pressure gradient remains constant, but because flow is increasing, but we're keeping that pressure low, we're going to have low resistance as well. Okay, so that's it. That's all we need to do. So why does pulmonary pressure increase during exercise, and how can we minimize that pressure?